This is Kyle Kidus, and this is the 4-bit microprocessor which I created in Logicen for the final project. I tried to make it as simple and clear as possible, and I used tunnels to do so. I learned about them from my classmates from some of our group meetings, which I really appreciated. Here's the clock and reset pins, and we go from the binary counter, program ROM, which has a series of instructions with every increment and will output 8 data bits per instruction, 4 to the decoder and 4 to a multiplexer. The 4 data bits to the decoder will help decide what 8 data bits to output to help determine functions to work in the microprocessor, such as ALU function selections, register write addresses, when to display content in the ASCII table, and so on. We have the multiplexer here, which, determined by the register source selection, will either take input from the 4 data bits from the program ROM or data from the ALU. And the register here, we have two registers, register 0 and register 1. And then together, they create 7 data bits that are outputted to the table for the display. The ALU, we have multiple functions such as add, or, and, or, not or. And when we want to subtract, this subtract pin needs to be equal to 1, and then the adder will then subtract rather than add. Here's a demonstration of the first part of the process. It will display hello brother Nichols, 3 plus 4 equals 7, 3 times 3 equals 9, and that's just done by doing 3 plus 3 equals 6, and then 6 plus 3 equals 9. Then we do a software subtract, 4 minus 3, and what we do is we set register 0 to 4, register 1 to -3, add those together, which we get 1, add that to register 0, 1, and then display that, and we get 1. Now we're going to do a hardware subtract, 4 minus 3 equals, and we're going to set both registers to 4 and 3, and we're going to do the add function with the subtract enabled, and we get 1. Output that to register 0, and we get 1. And that is the 4-bit microprocessor.